Hello students, this is a quick maths video about confidence intervals for mean. I'm going to be talking about a couple of different practice problems on how to find the confidence interval for a mean when I'm looking at sample data, specifically a sample mean and a sample standard deviation. The question is from a recent textbook question and a question that was on the notes for the second semester project. Ann and Tori wanted to estimate the average weight of an Oreo cookie to determine if that average weight was less than advertised. Let's keep that in mind. We're talking about less than advertised. They selected a random sample of 36 cookies. Here's my N. 36 cookies is the sample size. And they found the weight of each cookie in grams. The mean weight was X bar equals 11.3921 grams. Keep in mind that this is a sample mean. And similarly, this is a standard deviation of S equals 0.0817. They tell us it's a sample standard deviation because they told us it's the standard deviation from a sample. And they also tell us that it's lowercase s rather than sigma. That tells us it is from the sample, not from the population. So what we're going to do is, for this particular question, we're going to make a confidence interval for the true parameter, the true mean of the weight of Oreo cookies. And later on in the course, I'm going to show you how to do another type of test that is called a hypothesis test to do the same exact thing. Anyway, let's do the state step first. Pause the video and try to write down your state step and then come back to see if you got it the same as me. All right, for our state step, we wish to create a confidence interval for mean. Let's make sure that confidence interval is in there somewhere, and the parameter that we're talking about is in there, mean. The true population mean weight for an Oreo cookie, here's our context. We're talking about weight for an Oreo cookie, and then we're stating the level of confidence that we want. The confidence level is 95%. Just like any other handwritten or sentence question, we're going to be able to write this in slightly different ways. I'm not going to tell you exactly what order the words that you're going to put are in order to write an essay. So similarly, I'm going to tell you that you can write this in many different ways. You could say want or wish or whatever. You can say the 95% confidence level up here first. As long as it contains these highlighted bits, you should be good to go. All right, let's move on to the plan step. Remember, plan step is not just the thing that we are going to do, like the procedure that we're going to do, but also checking conditions. Pause the video, try this out, and then see if you got it right. All right, in our plan step, we're going to state that we're constructing a one sample t interval for mu. The important piece of information here is one sample. We're only looking at one sample of 36 cookies. Later on in the course, we'll talk about what happens when we collect multiple samples and look at their differences. We're using t for a reason that I'm going to mention in a moment. And we are also measuring or using a interval for mean, the true population mean. So I'm stating the parameter that I'm finding a confidence interval for here. And also mention that you're doing an interval, you're not doing a test. Later on, we're going to be talking about what that test is, as alluded to previously in this video. Now, just to clearly justify this, we say we are using a t interval. Why exactly are we using a t interval? Well, here's the reason. So I've created this handy flowchart for you to understand which critical value to use when you're making a confidence interval. First, you have to ask yourself whether you're dealing with means or proportions. If it's proportions, your decision has already been made. You're using a z critical value because you're able to use that standard error formula, and z critical value works well for that standard error formula. However, if you're dealing with means, you have to determine whether the sigma, the population standard deviation, is known or unknown. In the case that it is known, you're still using that z critical value. However, if the sigma value is unknown, you have to, instead of using sigma, like we talked about in class, you have to estimate using the sample standard deviation, which is s. If you're using that sample standard deviation, which is s, that means the confidence intervals are going to start acting like an accordion, right? They're going to start getting larger, and they're going to vary greatly in their size. So if those confidence intervals start varying greatly in their size, that means we can't use z critical value. We're going to have to use t critical value. The reason for that is a little arcane and requires a little bit more explanation. We talked about this in class, but suffice it to say the reason we're using t critical value is because the t distributions are just more spread out than the z critical value, and their confidence intervals are going to capture the true parameter more often than the z critical value will if we're estimating the standard deviation by using sample standard deviation. All right. Anyway, following this, we know that we're dealing with means. We know the standard deviation of the population is unknown, so we must be using the t critical value. That's why we're using a t interval. Next, and the way that I like to set up my paper is like this. Next, I'll have the do step all on the right-hand side of the paper, so I have all of this space in order to do the do step, and then conclude is going to be back over to the left-hand side. pause the video and try to write down that formula, and then come back to see if you got it right. All right, from the reference sheet, I know that a confidence interval is equal to the statistic plus or minus the critical value times the standard error of the statistic. All of these pieces of information can also be found either in the problem or from the reference sheet. Let's start filling this in. And the one thing that you might not have known already is the standard error of the statistic. I took the liberty of going to the reference sheet under standard error of sample statistic for one population X bar, and it gives me this formula. Wow, isn't the reference sheet fantastic? Anyway, now let's start filling out some of the pieces of information in this formula. So here's my X bar, here's my S, my standard error, and here's my S, my sample standard deviation, I should say, and I divided by square root of n to get my standard error. Now the t critical value is something that you can find very easily. I'm going to show you how to find it right now. You should remember from our conversation about this in class that a t distribution kind of looks like the z distribution, except it's just a little bit flatter. It looks like it got squashed down a little bit. And for every t distribution, because t distribution is really a family of distributions, all a bunch of different curves, you know that the degrees of freedom, the measure that essentially tells us how squashed it is equal to n minus 1. But just like with the normal distribution, we can draw that symmetrical curve, and we can say that if I'm looking for a 95% confidence interval, that means that 95% of the data is going to be in between these two sticks, and 2.5% of the data is going to be in the tails. So now what we need to do is find the critical value, the t critical value, which means we need to find the value of t at this value, at this point, where there's 2.5% of the data below it. So we're going to be using inverse t in our calculator. So I'm going to bring up my calculator here and go to second distributions. I'm looking for inverse t, which is the fourth one down in this particular calculator. And it asks for area, and we know the area down here is 2.5%. We're converting that to a decimal, so 0.025. And then the degrees of freedom, as it says over here, is n minus 1. In this case, the n, the sample size, is 36. So n minus 1 is 35. Entering that into our calculator gives us the t critical value of negative 2.03011. I'm going to take it to 5 decimal places, because take it to 5 decimal places if you want a 5. And one other thing that we talked about for this type of problem is that the negative symbol doesn't really matter, because what we're going to be doing is adding and subtracting that value multiplied by another number anyway. So I'm going to take that positive value, the absolute value of this essentially, and throw it into my critical value. So now I have everything in a nice tidy little package here. Let's start by putting just pieces of this into the calculator, because I don't want to throw the whole thing in the calculator. First of all, it's got a plus and minus, and second of all, there's a lot of stuff going on here. So I'm going to try to digest this one at a time. First, I'm going to calculate the standard error of the statistic by doing s divided by the square root of n. Then I'm going to multiply the standard error by the critical value to get the margin of error. So my margin of error is 0.02765. And then finally, I'm going to write down my confidence interval by taking this 11.3921, my point estimate, and then adding and subtracting 0.02765 from it. Now here I've found my lower bound, 11.36445, and I wanted to show you a trick on the calculator to do this a little bit more easily. Rather than typing this whole thing in, I'm going to press second enter. It gives me the previous thing that I typed in. I'm just going to go back here and put a plus here. Makes it a little bit easier to find our upper bound. And there you have it. We have our confidence interval that goes from 11.36445 to 11.41975. Now we don't really need the calculator anymore. Let's finish this off with a conclude step. Pause the video and try to figure out what you would write in the conclude step. And here's our conclude step. We know that we are 95% confident that 95% has to appear in our conclude somewhere, that the true population mean weight for an Oreo cookie. So we're talking about population mean. This is the statistical thing that we need to find. Then we talk about weight for an Oreo cookie. This is the context that we have to include. So we have our statistical part and our context part lies within the interval. We have to state that it's an interval, and we also have to provide the interval that's here. You can use this as a formulaic sentence. Just take out the things that are highlighted and add in whatever percentages, parameters, context, and actual numbers for intervals that you have, or you could reword it however you want. Just be sure to include the things that are highlighted here. All right, that is the video. That is how to create a confidence interval for a mean. If you want more practice on this, I have one more thing that you could try. This is a problem that also is from the textbook. we have a problem about NOx levels. You can try this problem out. Pause the video right now, try this problem just the same way that we did the previous problem, and then come back to see if you got it right. I'll show you the entire answer all at once. All right, here's your answer. The state step tells us 95%, tells us confidence interval, true population mean, that parameter, and gives us the context. In plan, we met the random 10% and normal large counts condition. And then in the do step, we use the confidence interval from the reference sheet. We substitute in all these numbers. Note that the t critical value was different here than the previous one because the distribution has a different number of degrees of freedom, 39 here rather than 35. And we found our confidence interval here. We wrote down the conclude step, including the percentage, the parameter, the context, and the interval. And then for letter B, it asks whether 1.0 grams per mile is inside the interval or not. It's true that 1, which is the limit for the EPA, is completely below that interval. The interval doesn't contain 1. So this is convincing evidence that everything within that interval is above 1. So the population mean is probably above 1. All right. That was the video on confidence intervals for mean. Good luck studying.